Okay, good morning. Welcome to
SummerMath number 33.
SummerMath number 33. Today we're talking about what we left off with at the end of last week about symmetries.
Yep.
And so we're going to do symmetries with our Lego, those aren't minifigures, what are they called?
Mixels.
Mixels, okay. So what are the names of our mixels here? Who's the yellow one?
Tesla. Fleur.
Tetro? Tentro, okay.
And Volk.
Volk? Okay. And so we've got them arranged in a square. I guess the square is sort of more like that.
Yeah.
And what the question here is a pretty interesting question. It's how many different ways are there to arrange these if we count all the different ways to manipulate them that end up being the same as the same. So it's not like on a keychain. So you can rotate.
Yeah.
And you can also flip.
Yeah.
And those are the same. So I want to first start out by ignoring the constraint.
So like just put them on a line?
Okay, so it's like you're just putting them on a line. So that we're saying that this and this would actually be different.
So that would make 24 arrangements.
Okay, why is it 24?
Because it's 4 factorial and there's 4 spots for the first, and 3, and then 2, and then 1.
Okay. I've got 4 choices for what I can put in the first spot.
Yep.
3 choices for the next spot. 2 choices for the next spot, and then only 1 choice there. So it's 4 times 3 times 2 times 1, which is?
24.
24. Okay? That ignores the constraint. And as you said, that's the same as if I just lined them up on a line. Here, I'll put different ones on a line. That's the same as if we just put them on a line.
Yeah.
But they're not on a line. Oops, sorry, that wasn't completely on camera. They're not on a line. The first, what's one easy way to make these the same?
Well,
Or to show that 2 things could be really the same as each other. What's the easy thing to show?
Just have this one automatically be at the top. Actually, just like unrotating something.
Okay, so one easy way is rotations. To say, really, this, and this we really want to say are the same thing.
Yeah.
Okay, so that's just with rotations. That's turning the square this way.
And there's 4 different rotations.
Okay, can you show them to me?
Well, this is 1, 2, 3, 4, and then we're back to where we started.
Then we're back to where we started. Okay, that's good. Okay, so of our 24, each one of those 24 should be the same as 4 other ones.
yeah.
So that leaves us with 6.
Okay, so we think we'll probably have 4 groups of 6, or sorry, 6 groups of 4, I mean. 6 groups of 4. Each one is equivalent to 4 other ones under rotation.
Yep.
Okay? But we now also introduce this idea of a flip.
Yeah. So,
Do we have the right colors here? Sort of. So
Yeah.
yellow,
yellow, orange,
blue, red, and orange. Okay. Is that on camera? Sort of. Okay. Now we have the idea of a flip. So I can flip like this.
Yeah.
So the red goes over here and the blue goes over here. Can you move the red? The red goes over there, the blue goes over there. These are really the same also.
Yeah.
Because if you think about a keychain, you might put the keychain down this way on the table, or you might put it on that way on the table. Who really knows?
Yeah.
Okay? So that introduces some other stuff that's going to be the same.
Yeah, but now what if you flip this way?
Oh, now that's a really interesting question. What if I flip that way
Then you
instead?
can-
But,
But
we always
then
want him
Well,
to be.
now hold on one second. Let's go back to what we had before so I line up our 2 things the same. So I've got yellow, blue, orange, red. One way was this flip that put the red over here. And the other way is this flip that moved the yellow and the orange. And maybe those are different. How could we check?
Well, we always want we always wanted this guy to be at the top.
Then
Okay.
you can rotate it up, but then it's the same as if we flipped these 2.
Look at that. Yellow, yellow, red, orange, blue. Amazingly, the 2 different flips end up being the same. under
that-
rotation.
Yeah, then that
So
means-
flipping this way and flipping that way are the same thing. That's pretty surprising,
Yeah.
I think, anyway.
Then you have to divide by 2. 6 divided by 2 is 3. 3,
Okay.
3 rotations.
Or another way to think about it, we've got 24 arrangements,
Yep.
and each one is the same as 8. 4 plus 4. 4 for the rotations, and then a flip and the 4 rotations.
Yep.
Each one is the same as 8, so we have 3 different arrangements with 4 things on a keychain if we allow rotations and flips to be the same thing. That's pretty amazing.
Cool.
Yeah.
Pretty cool. Okay, good job this morning, guys. We'll talk more about this tomorrow.